pretty soon. So once again, the way things are working out, we will not be having any type of final exam in here, okay? So your last major test is on chapter 8. And today we cover 8.7, and on Friday we cover 8.8. And we have class today, obviously, and we have class Friday for covering 8.8. Next week, you'll just be wrapping up section 8 and doing review work. So we're not going to meet at all next week. The following week, you're going to take the test on Monday. And then on that week, we will be having class on Wednesday and Friday. So nothing at all next week. There will be no meeting, no Zoom. But the following week, we'll meet on Wednesday and Friday. And when it comes to the test 2 weeks from now on Monday, I'm going to give it to you on that Monday. You have to get it done on Monday. You have 1 day to do the test. If you turn it in on Tuesday, you're going to be losing points. So you have to do the whole test on the Monday I give it. Okay? That's part of the deal. Now, we still have 2 quizzes we have to be taking on 8.7 and 8.8 coming up. So you're going to want to make sure you're really paying attention today. All right, well, let's get started. Get your notebooks out. And there are 2 topics for today. Okay, let me start with this. All right, so we are in 8.7 today. Factoring special products. Now, up to this point, the factoring you have done has been on quadratic trinomials, and you factored them into 2 binomials. And factoring means you write them as a product. So you've been taking those trinomials and writing them as a product of 2 binomials. Now we're going to do more factoring, which is more writing as a product. But these are special products that we studied a couple sections ago when we were multiplying. The first one is called a difference of squares. A squared minus B squared. When you have something of that form, it factors into 2 binomials. One's a sum and one's a difference of the square roots of these squares. So it factors into A plus B, A minus B. That's what we're going to do first. Then I'll talk to you about this one, and I've got another board with problems for that. So this is what you need to learn right now. Now, let me just say one other thing. When it comes to factoring, we always say we factor it completely, which means you're writing it as a product so that nothing else can be factored any further. And you always start every factoring problem with looking for a greatest common factor. That's what you have to understand. Every problem you're going to do in section 7 and section 8, the first thing you look for is the greatest common factor. and we factor that out if there is one. And then you look at what you have left and you see if that can be factored. And then you'll have factored it completely. So we're going to start with this first expression, x squared minus 25. Well, obviously, there is no greatest common factor that comes out. So we're ready to factor it. This is a difference of squares. You get x being squared and 5 being squared. So what does this factor into? Well, it's going to factor into the x plus the 5 times the x minus the 5. That's x squared minus 25. That's a difference of squares. And the x squared gives you the x, and the 25 gives you the 5. And you get plus and minus. Next problem, is there a GCF? And again, you can see no, there is not. And is this a difference of squares? Is 4x squared a square? Yes, it is. It's 2x being squared. And 49 is 7 being squared. So this is a difference of squares. So what does it factor into? You're going to get 2x out of this. And then you're going to get plus 7. And then 2x minus 7. All right? That's the difference of squares. Next one, 2x squared minus 200. If you look at this, you can see it's not a difference of squares. 2x squared is not a square, and 200 is not a perfect square. But what you have is what you're supposed to look for first, a greatest common factor. That's the first thing you need to do here. Take out a 2. That's the greatest common factor. When you take the 2 out, you're left with x squared minus 100. Now, we have factored this into a product, but it's not completely factored because this expression is a difference of squares and it can be factored. So to complete this problem, you have to factor this. And so you write down the 2, and then what is x squared minus 100? It's x plus 10 times x minus 10. And this is the final answer. That is completely factored. So that's what I'm talking about. Every problem, you first look for a greatest common factor that can come out, if there is one. And then you look to see if what's left can be factored. Is it a special form here? And it is. Now look at the next problem, 8 and 162. They contain a factor of 2. So you take the 2 out. You're left with 4x squared minus 81. And now we look at that. That's a difference of squares. 4x squared is 2x being squared. 81 is 9 being squared. And so we end up with a 2, and then we get the 2x plus the 9 times 2x minus the 9. And now we are done. So make sure you're really paying attention to these problems. All right, 2 more here. This next one, you look at it. Is there a greatest common factor? What number goes into each of these 2 numbers? And we can see that it is 3. And so you take a 3 out. That leaves you with 25x squared minus 4. And now you look at this, it's a difference of squares. And so that gives us the 3 times 5x plus 2 times 5x minus 2. And now we are completely factored. Okay? Now this last problem is kind of special. If we looked at it as it is a difference of squares. It's 3x plus 6 times 3x minus 6. But the problem is that that's not completely factored. Each of those could be factored some more. Okay? So the first thing you're supposed to do with these problems is look for the greatest common factor. And here we happen to have a 9. So you take a 9 out, it leaves you with x squared minus 4. That's what we want to do. Then you put the 9, and then you get the x plus 2, x minus 2. All right? So that's very important. So make sure you read the book tonight for section 8.7 and you look at this special form, a squared minus b squared. And you look for a greatest common factor. And then you factor completely. Okay, now that's one part of 8.7. There's another part. And here's another special product that we had. If you remember, we were learning how to square binomials a couple sections ago. And in squaring a binomial, the rule was square the first and get a squared, double the product and get 2ab, and then square the last and get b squared. That's what we're going to study now. So here are some problems of that type. Okay, so we start with x squared plus 2x plus 1. Now again, with these, the first thing you look for is greatest common factor if there is one. Well, here there's nothing that goes into all 3 of those. And so we have to look at this and see if it can be written as the square of a binomial. Can it be factored as a binomial square, which would make this what is called a perfect square trinomial? The first term has to be a perfect square, and the last term has to be a perfect square. And then if it is the binomial you would get, that would be squared would be the square root of the x squared, which is x, and the square root of 1, which is 1. And the sign will be the sign of the middle term plus. And what we end up with here is x plus 1 squared. And we can check our answer, square the first, you get x squared, double the product, you get 2x, square the last, you get 1. Now, it turns out you could also factor this as a trinomial and use that method, and you would get x plus 1 times x plus 1, which is x plus 1 squared. So these could be done as trinomials. But if you can recognize them as perfect squared trinomials, you go right to the binomial square. Next problem, x squared plus 6x plus 9. Again, no GCF. The first is a perfect square, the last is a perfect square. So then we ask ourselves, what binomial would it be? For the x squared, you get x. For the 9, you would get 3. And for the sign, you go to the middle, you would get plus. And then you check your answer. Square the first, you get x squared. Take the product, you get 3x. Double it, you get your 6x. Square the last, you get your 9. So this factors into this binomial square. So these are perfect square trinomials. These things take a little bit of work. You've got to recognize them. Now you look at the next trinomial. That's not a perfect square, and that's not a perfect square. But you've got a greatest common factor of 2. So you take the 2 out, then it gives you x squared plus 8x plus 16. And now we ask, are we completely factored? Is this factored? And you can see it's not. It needs to be factored. It has a perfect square here and here. And so what you're going to get is that 2, and then you're going to get a binomial square. For x squared, you're going to get the x. For 16, you're going to get a 4. And for the plus, you're going to get a plus. And if you square x plus 4, you get x squared plus 8x plus 16. And then you have your 2 in front. So this is what I mean by the fact that every problem you do, you first check for a greatest common factor. And you factor that out. Then you look at what you have left and see if it's a special form that can be factored. This is a lot of what we're going to do in section 8. It's a lot more the same in section 8. So we're really learning both sections here. All right, next problem. Take a look at it. And what do you recognize? A greatest common factor, right? And so what is it? It's a 3. So you take the 3 out, you get x squared plus 10x plus 25. And then you get 3, and you get what binomial? X squared gives you x, 25 gives you 5. And the plus there gives you a plus. And you get 3 times x plus 5 squared. Okay? Here we go, second last one. You have a 5, a 20, and a 20. So we can see that 5's the greatest common factor. Leaves you with x squared plus 4x plus 4. If you distribute, you'd get your 5x squared plus 20x plus 20. And now we have that 5. And now what binomial square do we have right here? X squared gives you x, and the 4 gives you 2, and the plus gives you a plus. I should have had some with a minus here, then that would have been a minus. But you get 5 times x plus 2 quantity squared. Okay, and then the last problem, there is no GCF, but this is a perfect square trinomial. First is a perfect square, the last is a perfect square. And so what binomial is it going to be? X squared gives you x, 36 gives you 6, the plus gives you plus, quantity squared. And those are the two special products that we're doing, the two special products that we're factoring. Difference of squares and perfect square trinomials. Okay? So hopefully you've been paying attention and this all makes sense with you.